so 9.5 part 1. So in 9.5, we're going to talk about polar coordinate system. What we're typically used to is seeing a rectangular coordinate system. So we're used to our XY points on our XY graphs. This is rectangular. We would have a point, something like 2, 1. We'd go to the right 2, up 1. This is a unique point. There's no other point that we would have that ends up in this place on our graph. With a polar coordinate system, our points are not unique. So we could have different points ending up in the same spot. So this is what a polar coordinate system looks like. It almost looks like a unit circle. So we're bringing back radians. We're going to be graphing with them. So to form the polar coordinate system in the plane, we fix a point O called the pole. The pole is the origin. So the very center or origin is called the pole. And we construct from O an initial ray called the polar axis, as shown in the figure. So our polar axis is where we start. That's kind of like our x-axis that we have here. This is our starting point, our polar axis. Our point is going to be r comma theta, where theta is our directed angle and r is our directed distance. So r is kind of like a radius because our polar coordinate system is almost like a circle. So r is similar to a radius here, but it's the directed distance. Next page just says the same thing. In our polar coordinate system, we're going to have r comma theta, where r is the directed distance from the pole to the point, and theta is the directed angle. We go counterclockwise from the polar axis. So we start at 0, we go counterclockwise, similar to what we did in the unit circle. We would go up for positive angles, and we go down from the polar axis for negative angles, similar to our unit circle. So in example 1, we're going to plot the point. So first thing we want to do is start with theta. We're going to find where pi over 3 is. So on our polar coordinate plane here, we've got pi over 3 right here. R is the directed distance. So we're going to go 2 units from the pole. So the pole is the center. Each circle that we have here is like 1 unit. So we're going to go out 2 units. We have 1, 2. This would be our point. So we're plotting points here. It's not drawn like an angle. It's not drawn like a line. It's just a point. So that would be our point. We could call it point P. Now, like I said before, on a rectangular coordinate system, we have unique points, but in a polar coordinate system, we can come up with different points, so different coordinates that will end up in the same spot. So we could call this, remember we said we could go in the negative direction. So if I went in the negative direction around this much, we would just subtract 2 pi. If we wanted to go in the negative direction, we could subtract 2 pi. What do I do if I'm subtracting with fractions? What do we need? A common denominator, so I could make this 6 pi over 3. So what's pi minus 6 pi? Negative 5 pi over 3. So 2 comma negative 5 pi over 3 would end up in that same spot. We just would go in the negative direction around that way. We could have also added another 2 pi and gone in the positive direction. So if we went around pi over 3 and then went another 2 pi all the way around, we'd end up in the same spot. So we could add 2 pi over 3 as well. which we said, or just 2 pi, which we said is 6 pi over 3. So if I had pi plus 6 pi, that would be 2 comma 7 pi over 3. So all 3 of these coordinates end up in that same spot. These are all coordinates for that same point P. So for the negative one here, if we went down, we would go from 0 and we'd go down 5 pi over 3. So we'd go this way to the point. So you are technically going down because we're going down from the start, but it's not like a rectangular graph. It's not going to be like negative, really. We would just go around 5 pi over 3, but in the negative direction. So for B, we want to plot the point 3 comma negative pi over 6. So starting with negative pi over 6, so we always want to start with the angle, figure out where that is. Since it's negative, we're going to start by going down. You can either convert this into the positive coterminal angle and find out where it is, or if you want to see how far do we go in the positive direction, pi over 6, we would go 1, 2, so we'd go around 2, up, so we'd have to go in the negative direction 2, so we'd go down 2. So we would end up here. So this would be where negative pi over 6 is. And then since r is 3, we go 3 units from the pole. So if we start at the center, we're going to go out 3. So 1, 2, 3. So this would be our point P. What would be another coordinate for our point P? 3 comma what? 11 pi over 6, which you could also find that just by adding 2 pi. So when we add 2 pi, this would turn into 12 pi over 6, which we would get 11 pi over 6. We could find another angle by subtracting 2 pi. We also could have negative r, so a negative directed distance. So using this same point here, I'm going to show you with the board. If we extended this line, so we have 11 pi over 6, if we extended this all the way through straight here, if I went to 5 pi over 6 and said that my r was negative 3, 5 pi over 6, a negative r, we would go to 5 pi over 6. A negative r means that we go backwards. So this would also have that same point P. So we would go to 5 pi over 6 to here, but a negative r means that we start at the pole and we go away from the angle. So all 3 of these points, or all 3 of these coordinates, end up at the same point. So if we have a positive r, I'm going to write that here. So these 2 ended up being positive r's. Positive r's, we go towards the angle. A negative r, we go away from the angle. So on the next page, we have the math behind how we can find more points. So in rectangular coordinates, each xy has a unique representation. We said this before. This is not true for polar coordinates. For instance, the coordinates r comma theta and r comma theta plus 2 pi would be the same point. So we can add and subtract 2 pi as many times as we want, and we'll end up in the same spot. It says another way to obtain multiple representations of a point is to use negative values for r. Because r is the directed distance, negative would mean that we go away from the angle. So if we changed our r to negative, we would add or subtract pi each time. So we would add or subtract pi. So if we keep our r the same, we add or subtract 2 pi. If we change our r to negative, we add or subtract pi. So these are super, super, super important. One other important thing on this page, it says the pole is represented by 0, comma, theta, where theta is any angle. So if I had 0, comma, 3 pi, this would end up at the pole. If I had 0, comma, 6 pi over 5, this would also end up at the pole. If I had 0, comma, 1000 pi over 3, this would also end up at the pole. It doesn't matter what our theta is. If r is 0, your point is going to be at the pole. So let's look at example 2. We want to plot the point and then find 3 additional polar representations of this point that are in between negative 2 pi and positive 2 pi. So because it gives us this restriction here, we can't just keep adding 2 pi every single time to find a new point. We're gonna have to use our negative points too. So let's start by plotting our point. I'm gonna start with theta. So theta is negative 3 pi over 4. So I could find out how far I go 3 pi over 4 in the positive direction. So I'm gonna go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go up 9. So for negative 3 pi over 4, we're going to go in the opposite direction. So I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be where negative 3 pi over 4 is. We could also find that by adding 2 pi to it. We could find a coterminal angle. Now our point, since our r is 3, we're going to go 3 units away from the pole. So away from the pole, but towards the angle. So 1, 2, 3. So this would be our point. Now, just by looking at this, we could say that 3, 5 pi over 4 is another representation of this point. It's another coordinate for this point. You can find your additional points just by looking at it, but you could also do the math that we talked about. So keeping r positive, I would have 3, 3 pi over 4 plus 2 pi. So I can add or subtract 2 pi to it, as long as our theta is going to be in between negative 2 pi and positive 2 pi. So I'm going to add 2 pi. I need a common denominator so I can make this 8 pi over 4. So our point here would be 3, 5 pi over 4. Is 5 pi over 4 smaller than 2 pi? Think, is 5 over 4 smaller than 2? Yeah, so this works. So this is going to be, and we set it here. That was the same angle. So this is a point that we have. Let's keep 3 positive, and I'm going to subtract 2 pi. So we have negative 3 pi over 4 minus 2 pi over 2 pi. And I can make that 8 pi over 4. So this would be 3, negative 11 pi over 4. Is negative 11 pi over 4 in between negative 2 pi and positive 2 pi? No, it's not. It's outside. If we divided 11 by 4, we would get negative 2 point something-ish, which is outside of negative 2 to 2. So this does not work out as a point because it's not inside of our window that we're talking about. So now let's change our r to negative. So negative 3. I have 3 pi over 4. What would I have to add and subtract when I change my pi to my r to negative? We add or subtract pi. Perfect. So when we change r to negative, we're going to add or subtract pi. So I'm going to start by adding pi. Since we're adding pi, I'm going to change it to 4 pi over 4 to give me a common denominator. So this would be negative 3 comma pi over 4. Is pi over 4 in between negative 2 pi and positive 2 pi? Yep. So this works as a point. If we were to graph this, we would go up 2 pi over 4, so our theta would be here. Since it's negative, we would go away from the angle. So since pi over 4 is here, we would start at the pole and go away from the angle 3. So 1, 2, 3. That ends up in the same spot, which that's our goal, was to end up in the same spot. So now we have 2 angles, we need 1 more. So keeping with the negative, I added pi. Now I'm going to subtract pi. So negative 3 pi over 4 minus pi. So I can change this to be 4 pi over 4. Let's give me a common denominator. So that gives us negative 3 comma negative 7 pi over 4. Is this in between negative 2 pi and 2 pi? Yep. So this also works. So you can just double check if you want to. Go to your graph, go to negative 7 pi over 4. So we'd have to go clockwise starting down. And then we would go away from the angle to negative 3. And it would end up in the same spot. So these are 3 additional polar representations. Any questions here? So the most important thing here is if we keep r the same, then we would add and subtract 2 pi to our theta. If we change it to negative r, then we add and subtract pi to our theta. And this will give us our additional points.